end of the lesson, you'll be able to identify the main components on the motherboard and explain how the components of a computer communicate with each other. Hi there. Welcome to our first lesson on IT hardware and software. Now today, we're going to watch as Zamo and Morwa start to build a computer. Now this is going to help us to learn about the main parts or components of the motherboard. Now it sounds complicated, but actually it's pretty simple. Now we know that a computer is an electronic device that receives data called the input via something like the mouse or a keyboard. That input is then processed and turned into output, which is usually displayed on something like a monitor or as hard copy on a printer.
Wow, Zamo, we've got lots to do today, hey?
That sounds like Zamo and Morwa.
I'm so excited, though.
I'll tell you what, I'm going to leave them to it. I'm out of here. See you later.
Wow.
Holidays.
We've got lots to do today.
I know, I'm so excited. Today is a big day. It's the start of the holidays and we get to build our own computer.
So where do we start? I have absolutely no idea.
Well, luckily I do. Basically, we start with the motherboard and the CPU.
And a CP to you too. Have we got one?
Yeah, Murray let me go get all the extra stuff out of his storage. So we've got everything right here.
So what does a CPU do?
Well, it takes care of all the processing, but we also need RAM.
Do you remember what you learnt about the CPU and RAM? The central processing unit, or CPU, does all the work in a computer. The other components either store the data or help the CPU to move it around the motherboard to different components or devices. RAM stands for Random Access Memory. RAM is the storage area used for all the things currently happening in the computer. It stores all the running programs, as well as the data that those programs need. So, the CPU gets its instructions and its data from the RAM.
Didn't we learn that RAM loses all its data when the computer's power's off?
Yeah, it's very volatile.
So how does the computer know how to start up without any instructions?
Well, that's where ROM comes in. ROM is short for read-only memory.
On the first computers, you couldn't change the program on the ROM. Nowadays, we have EPROM, Electronic Erasable Programmable ROM. This software lets you erase and update the information on the ROM. And that's good, because the ROM chips are fixed onto the motherboard.
You still haven't answered my question. How does the computer know how to start up without any instructions?
Well, when you turn on the computer, the CPU looks for its first instructions from a ROM chip called the BIOS. Well, you see, the CPU is told to check that the hardware works, get all the devices ready, and loads the operating system from the hard drive into the RAM. Then the OS takes control of the computer and tells the CPU what to do.
So how do all these components, these RAMs and ROMs and BIOSes and all the other stuff interact with all the other components? How do they communicate and tell each other what's happening? It all seems so complicated.
Well, the motherboard is like the big brain that controls everything.
Well, apart from being the big brain, as Zamo calls it, the motherboard also has other jobs. It's the central unit for the attachment of components and devices to sockets, slots, or ports so that they can communicate. A CPU is an example of a component and a keyboard is an example of a device. Different devices are connected via wires called buses, etched into the motherboard to transfer signals between them. The motherboard provides power to its components and devices plugged into a USB port. The motherboard can also use its ROM chips and circuitry to control and manage basic standard operations.
It sounds like a computer is just a load of little bits and pieces put together.
Yeah, it's called a modular design. You see, if a computer was one piece, then you'd have to either replace the whole thing or upgrade it entirely if one thing broke. But with a modular design, then you can replace or add 1 or 2 pieces if something breaks.
Wow, you sure do know quite a bit about computers, don't you?
Yeah, well, Murray tells me stuff and I get some tips from my dad.
So, Brainiac, how does communication happen on a motherboard?
Don't worry, I'll show you. But we need to find one that's compatible. What that means is that our motherboard must be designed to work with our components, our CPU, our RAM. Aha, this one is perfect. You see, communication is sending a message through something to a receiver. For example, I am a sender sending a message to you, the receiver. I send my message through the air, which is the medium, and you, the receiver, receives it through your ears. Get it?
Of course I get it. I know what communication is, man. I'm not that stupid.
Sorry, I was just trying to explain the process.
I just wanted an example of how communication happens inside a computer. That's all.
Now, different devices communicate with each other by sending electronic signals to each other in the form of electric current. Now, in the previous series, we learned that a very low current is represented by a 0 and a high current is represented by a 1. So, we also learned that these 0s and 1s are also called bits. So when a printer is ready to print, it sends out a signal.
So that's how communication happens.
Yes, there are different types of communication over the same physical space. The first one we're going to look at is parallel communication. Do you know what that is?
In maths, we learn that parallel lines don't meet. But there, all the wires making the connections link up, so I'm not sure.
Well, in this instance, parallel communication means a group of bits is transmitted at the same time over a group of wires, but these wires are not parallel. Then you get serial communication.
And I'm guessing that cereal has absolutely nothing to do with what I had for breakfast.
That is so lame.
Sorry.
Serial communication is when bits are transmitted one by one over a single line.
Okay, I think I get it. Communication is either parallel, meaning at the same time, or serial, meaning one bit at a time.
Hey, not just a pretty face I see.
Now, something else we need to consider in communication is timing. Now, there's synchronous and asynchronous transmission. Asynchronous transmission is when the signal is sent at slow and irregular intervals. This means the sender can send a message even if the receiver is not ready to receive it. Sending an SMS, now that's a good example. Synchronous transmission is for high-speed data transfers. The receiver knows exactly when it will start receiving data, and the transmission is regulated by a clock and lasts for a given period of time. Lastly, we need to know about the speed and the direction of the data transfer, and we have 3 different options. Simplex is transmission in one direction. For example, from the keyboard to the computer. Half duplex sends signals in both directions, but not at the same time. For example, the hard drive can send and receive signals, but not at the same time. Full duplex is when signals travel in both directions at the same time. It's similar to using the internet with an ADSL line. You can download from the internet and send a fax at the same time. So, let's summarize what we've just gone through. The communicating devices must choose either a parallel or a serial communication channel. It must be decided whether the sender can send at any time, or if the receiver must first give a signal to say that it's ready. In a system, one device must be the sender and one the receiver, or if they can do both tasks, they must know if they're allowed to transmit data at the same time. But, and it's important to remember this, the 2 devices must be using the same method of transmission. Otherwise, there'll be no communication.
I think I'm beginning to see how communication and the different components are linked together, but
Sorry. Ooh, it's my dad. I have to take this. Hi, Dad. Ooh, I'm so sorry. I completely lost track of time. I'll be there in no time. Okay, cool. Okay, bye. Listen, I have to go. I'm meeting up with my dad for lunch and I completely forgot. We'll complete building this computer tomorrow. Is that okay?
That's fine, but I still think you need to get a better communication system.
Yeah,
going
sure.
there.
We'll sort that out tomorrow. You have a good time. Ciao.
All right, bye.
Well, that's all for today's lesson. All that remains is for me to give you the task. Draw up a diagram for a wall chart showing the different components found on the motherboard.